In this video, we're going to talk about closures and iterators. Well, without further ado, let's dive into it. Here's a value, step, and here's a tiny function that uses it. Bump never declared step. It reached out and grabbed it from the scope around it. Now you can tell or call bump like any function, and it's still gonna remember the step, and that is closure. Go ahead and dig more into closures. You already know about function. They need a name, a parameter types, or a return type. It's like a whole thing. A closure is the same logic, but it's more like it's written inline, and the pipes hold the parameter instead of a function name. And usually you drop even more. The compilers infer the types, and one expression body needs no braces. And that is the shape that we write when writing closures. When a closure uses an outside value, it captures it. And there are three ways to do that. So say only reads name. So it borrows it. So basically it's shared. You can call, say, as many times as you like. That closure is an fn or function. Now push changes the list, so it borrows it mutable way. So it's like still callable, like you can still call it as many times as you want, but it can also mutate, and that one is a FnMut. Now move takes ownership. It consumes the whole, it swallows the name as whole. So it can run once, and that is FnOnce. So it's not like a label you pick, it's just how you use a capture to pick as a trait, something like that. Do you remember traits from one of our last videos where we went over generics, traits, and lifetimes? Well, over here, FnMut, and FnOnce are three of them, actually. And they nest, so let me explain what I mean. So FnOnce is the loosest, so you can call it at least once. But FnMut adds like calling again and again with mutation. But only function type is like the strictest. It's call only again and read only. So every fn is also an FnMut and is also an FnOnce. When a function asks for a function fn, it is actually asking for the most flexible kind, and reach for the move that when the closure has to outlive the scope it was born in. An iterator sounds fancy, but it is one method. Next, it hands back the next item or none when it is done. So if you call iter to get 1, then call next yourself, first time you get some 10, again some 20, each call, one item wrapped in some. And when the item run out, next returns none. And that none is exactly how a for loop knows when to stop. It's a for loop is this automatically. Now, in terms of iterators, you get three ways, and they might feel quite familiar. So, iter borrows each item to read. Iter_mut borrows it mutably, so you can change it in places. And then into iter takes ownership. It consumes the collection borrow, mutate, and take, and the exact same three modes as closures. Over here, where both halves of this episode meet, adapters are iterator methods that takes a closures. Map runs your closure on every item. A name goes in and its length comes out. Filter keeps an item only when your closure says true, so we keep the longer names. And the trick, that is, each adapter returns another iterator, and that is why you keep chaining them one after another. So this part actually confuses a lot of people. Well, iterators are lazy. Let's look at this map. On its own, it prints nothing, not one hit. The closer never even runs. But over here add collect, and suddenly it starts running once per element. Collect is the thing that asks. Let's build a real pipeline and start with 6 numbers. Iter walks them 1 through 6, and nothing has happened yet. And remember, iter is quite lazy. Now filter keeps the even one, 2, 4, 6 falls through, and map doubles each 1, 4, 8, 12. And collect is what finally asks. It pulls everything through and it gathers it into a vec. So 4, 8, 12, and here's the thing. The whole chain compiles down to one tight loop. What actually gets asked for these situations? Well, a consumer. So sum pulls every value through and adds them up 10. Now the pipeline really runs. If you count and see, like, the count works the whole thing and tells you how many came out, and which is like 4. And fold is the general one. It carries an accumulator across every item. Then you decide what to do with each step. Sum, count, even, collect are folds with the boilerplate hidden. It might seem like that all this chaining is quite slow, but actually it is not. Because when you do this, here's what you write. And here is what the compiler turns it into. It's like the exact loop you'd write by hand. And more like the same machine code, just no extra cost for the entire nice syntax. It's like high level read and low level run. And that is the whole thing. And this is why people love using iterators in Rust, because you describe what you want and Rust runs it fast. That's it for closures and iterators. It's more like function that carry context, pipeline that just stays fast. And in the next video, we're gonna look into more about modules and all the cargo stuff. So yeah, thank you so much for watching. See you on the next one.